Hey everyone, we're just going to start working through chapter 2, following along from yesterday, chapter 2 of Think Python. As of time of this recording, I don't know what I'm going to name this series. Trying to be a beginner, I guess. So I'm going to, just 1 second. Sorry, there's some background noise I was trying to kill. So yeah, I'm not entirely sure what I'm going to name this series, but probably you guys will know when you guys are watching this video, whoever is watching this video. So yeah, I'm trying to install Windows 10 as well, which is a whole different thing because the person I'm working for and also a lot of people here would probably be doing things on Windows. So I am emulating Windows, which means this is super slow and super irritating, but that's okay. So going on to chapter 2, we ran this first cell that's in all of these notebooks. The first cell just needs to be run. It's just downloading the file and importing some module that they need. I don't understand exactly what. Probably maybe for some of the markdown stuff or something else. I don't know. Variables and statements. In the previous chapter, we used operators to write expressions that perform arithmetic computations, correct? So we did pluses, minuses, your basic arithmetic. In this chapter, you'll learn about variables and statements, the import statements, and the print function. And I'll introduce more of the vocabulary we use to talk about programs, including argument and module. Let me just check. Are these... Can I run them here? No, I can't. This is just the render. But it seems something like this. In the previous chapter, assignment statement. Yeah, okay, it's the same book. I just wanted to make sure. In Python. Okay, chapter 2. Variable is a name that refers to a value. To create a variable, we can create an assignment statement like this. So n equals 17. So now the variable n is equal to the value 17. An assignment statement has 3 parts: the name of the variable on the left, the equals operator, and an expression on the right. In this example, the expression is an integer. In the following example, the expression is a floating point number. Pretty straightforward. And in the following example, the expression is a string. Message equals and now for something completely different. Okay. When you run an assignment statement, there is no output. Python creates the variable and gives it a value, but the assignment statement has no visible effect. However, after creating a variable, you can use it as an expression, so we can display the value of a message like this. Now, that is true in Jupyter Notebooks, but it's not true in like actual, if you're writing a script or something like that, you'd have to do print message like so. Print is a function that prints to, oh yeah, you can print it to a file, or okay, I don't actually know what all print does. Prints the value to stream or to std out by default. String inserted between values, default is space. End string appended after the last value, default a new line. File, a file-like object, stream, defaults to the current std out. Okay, anyways, whatever. I don't want to get into this. I don't care about the print function that much. So yeah, you get all this jazz. You can print, and you can also use variable as a part of an expression with arithmetic operators. So n, if you recall, is 17 plus 25 is 42. AKA the answer of everything. And 2 times pi is 2 times pi is 6.28, blah, 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 blah. Now you can use a variable when you call a function. Yeah, so you can give pi to round instead of giving the actual value of pi. And also I think you can give a much higher precision value of pi if you import the math module, but that's a different story. Len message 42. Okay, so and now for something completely different, len of message 42. I like how they planned that out. That's funny. State diagrams. A common way to represent variables on paper is to write the name with an arrow pointing to its value. Okay, what is this doing? Common way. So from diagram, I think diagram, yeah, diagram is the thing of their own. Common way to represent variables on paper is to write the name with an arrow pointing to its value. Okay, so I'm not gonna worry about this code. It's just some code from their own thing. In some math, make binding message, and now for something completely different, make binding n17, make binding pi this, frame equals frame, binding 3, binding 2, binding 3, binding. Yeah, okay, so this is just setting up for the diagram functions to actually display this. This is not code I very strongly care about. I mean, I could dive into them and how they're working, but I just don't care. This kind of figure is called a state diagram because it shows what state each of the variables is in. Think of it as the variable's state of mind. We'll use state diagrams throughout the book to represent a model of how Python stores variables and their values. Okay. Variable names. Variable names can be as long as you like. They can contain both letters and numbers, but they can't begin with a number. It is legal to use uppercase letters, but it is conventional to use only lowercase for variable names. The only punctuation that can appear in a variable name is the underscore character. It is often used in names with multiple words, such as your name. Accidentally. There you go. Such as your name or airspeed of unladen swallow. Okay. If you give a variable an illegal name, you get a syntax error. The name million is illegal because it contains punctuation. So, yeah, there you go. If you run this will give a syntax error. I still don't know what this magic is. It's supposedly for pre-printing the error, but even if you don't have it, it still does it quite nice. So I'm guessing this is something that is specific for actually using Jupyter notebooks that doesn't really matter in Google Colab, and I guess they just have the same notebooks for people who want to run it on their own machines. Similarly, starting with so this ended with a punctuation, but just using any punctuation other than underscores doesn't work for variable names. So this starts with a number. You can't start with a number. You can have a tremor. So this it's gonna throw a syntax error right now. Right, and then I'm just going to do this, trombone 76, and boom, there's no issue, right? So I'm just going to keep that as is, run it so you guys know that there's an error there. Class is also illegal, but it might not be obvious why. So class, I'm just going to jump ahead, they're going to talk about this, but class is a reserved keyword for defining class objects. And there are many such reserved keywords that is illegal to use as a name. And then there's many other situations where variable names can shadow some other name in someplace else, and those aren't illegal to use, and if you're careful, it's fine. But just as good practice, don't do it, because it's better to have a locally scoped variable name that doesn't conflict with something else. Which, if you've been seeing some of my previous episodes, something rough can do, or any other linting solution. Flake8 is another common one. rough is the best easily. I don't even know. I love rough so much. Okay. Turns out that class is a keyword, which is a special word. Hey, I just talked about that. Or the special word is used to specify the structure of a program. Keywords can't be used as variable names. Here's a complete list of Python keywords. False, none, true, and as, assert, async, await, break, class. So all of these are just essentially different keywords. I'm going to see if I can go through all of these and explain them. So false is false, true is true. So the type, not the type, false and true are essentially Boolean values. So they are literal values, but they're also reserved keywords because it's the only way to, not the only way, I mean, I guess you could use like an integer or something, but like that is of the type bool. None is another one that's just it's a specific type for null, right? So something that just doesn't exist, that's none. And if you're doing some sort of conditional statement, this and this, as, that's aliasing, so like import as or with open as. Assert, async, assert is like for testing, async It's so like you can assert like a function has a specific return type or a specific behavior. Async, await, these are both used for asynchronous calls. Break, just like end a loop prematurely. Class, as we discussed, creating a class continues. So don't break the loop, but skip the rest of the loop and start the next iteration. Def, I don't know what del is. Del is delete, but I don't know what it, like why would you use del? I think I'm gonna name the series an intermediate trying to be a beginner, because I'm like reading through all these things and I'm like, wait, it was super simple for me, and I think I should keep it that way. I think the last episode I tried to be a bit too much, but yeah. The del statement allows you to remove one or more references. Python. The del statement in Python used to remove references, effectively deleting them from a given scope or container. This action can lead to the object being garbage collected if no other references to it exist. Here are the primary reasons scenarios for using del. Deleting variables / names. Del can remove a variable name from the current namespace, making it undefined. Attempting to access my variable after this would raise a name error. Removing elements from lists. Del provides a concise way to remove elements or slices from a list by their index or range of indices. Okay, there you go. Nice. Removing key value pairs. Oh, do that too. Nice. Deleting object attributes or attributes of an object can be removed using del. Okay. Okay, so there is actually great, because this is the thing, like the point it noted earlier about dealing from given this action can lead to the object being garbage collected if no other references to it exist. I think that doesn't matter, because Python's actually fairly efficient about garbage collection, and you have to be doing something super complicated, I guess, to have a memory leak issue in Python. You can have that in like other programs, but I don't know. I actually don't know. From keyword, import keyword list. Okay. Is that a real function? I don't know, my keywords are displayed in. Okay, so you don't have to memorize this list. In most development environments, keywords are displayed in a different color. If you try to use one as a variable name, you'll know. Yeah, so don't worry about that too much. Import statement. In order to use Python features, you have to import them. For example, the following statement imports the math module. Import math. A module is a collection of variables and functions. The math module provides a variable called pi that contains the value of a mathematical constant denoted pi. We can display its value like this. Yeah, I'm just gonna import math separately and then math.py. I mean, I don't think, I think math is imported somewhere else. I think earlier on, or I think in the diagramming. Yeah, see, it's imported already, so I didn't need to do that. To use a variable in a module, you have to use the dot operator between the name of the module and the name of the variable. Yep, the math module also contains functions, for example, sqrt, which computes square roots of things. So math.sqrt. And POW raises one number to the power of a second number, math.pow. You can also use exponentiation. At this point, we've seen two ways to raise a number to a power. We can use the math.pow function, or either one is fine, but the operator is used more often than the function. Yeah, that's true. I don't understand why this function. I think it existed before the exponentiation operator was introduced, and it's probably just left untouched to ensure backwards compatibility with other Python. I think at this point there's loads of things like that, even with typing and all that. I feel like Python is moving towards a 4.0 release, like maybe around 3.2. Like I think we'll call it before 3.20. Just a random thing. Expressions and statements. So far we've seen a few kinds of expressions. An expression can be a single value like an integer, floating point number, or string. It can also be a collection of values and operators, and it can include variable names and functions calls. Here is an expression that includes several of these elements. Boom. Right. So an expression doesn't need to be just arithmetic, as was in chapter 1, and you can just like add things around, use functions, all Gucci. We have also seen a few kind of statements. A statement is a unit of code that has an effect of no value. For example, an assignment statement creates a variable and gives it a value, but the statement itself has no value. Statement is unit. We've also seen a few kind of statements. A statement is a unit of code that has an effect but no value. For example, an assignment statement creates a variable and gives it a value, but the statement itself has no value. Okay, yeah. Right, so this is a statement. And this is an expression. All right, cool. Oh, sorry, didn't mean to do that. So this is an assignment statement, basically, is what it's just trying to say. I think that's just a formalization thing that I'm slightly in mind, like, what? Statement, yes, it's a statement, okay? Technically, this is a statement, this is an expression. Similarly, an import statement has an effect. It imports a module so we can use the variables and functions it contains, but it has no visible effect, right? Import math, right? Math, I think importing can throw someone new to programming off, like, what is that? I don't understand, and they'll just do it blindly. But I'm going to try and attempt an explanation. Like, for example, let's say you live in a country where there's something you want, right? That is not available in your country, and you have to import it. Literally, that's like the most common usage of the term. Everyone knows what an import is, right? So you're literally going to do that. You're going to go to their Amazon or some other third-party store, and you're going to import it. You'll pay whatever is needed, and you bring it to your house for you to use. Now, technically, importing is essentially a product or a service that is brought into one country from another. The act of bringing goods or services to buy goods, etc. from, okay, so everywhere it's always foreign. But you could honestly consider, actually, yeah, you can consider the entry point of your program. So whatever file where you're writing your code, so in this case, it will be this Jupyter notebook itself that we're looking at, as the country that the program begins in, and then the program needs something from another country, so it imports it to get access to it. These other countries, or modules as we call them, are essentially what have different units of code that we can use, right? So this is actually a really powerful and important thing, because there's huge amounts of packages and other things you can install other than what comes bundled with Python, which is also known as a standard library, which is a common term across multiple programming languages. And you can import those into your program and use them, like the stuff from the base library, the standard library, whatever you want to call it, and also stuff that you install, other packages and stuff, other pieces of code that do things, right? So that's really powerful and really important thing. Okay, we already read this. Computing the value of an expression is called an evaluation. Running a statement is called execution. I'm just gonna run this again to get this stupid thing to clear, because I hate it. Computing the value of an expression is called an evaluation. Running a statement is called execution. That's, I think, that's one way to say things, I guess. When you evaluate an expression, the result is displayed, duh. But if you evaluate more than one expression, only the value of the last one is displayed. To display more than one value, you can use the print function. So it also works with floating point numbers and strings. Yeah. So yeah, print can be used to print anything to the console or the std out, which at this point is captured by Jupyter. So one thing about this that I want to note for whoever's watching this, or if you're going through this book, essentially, and I mentioned this already earlier in the episode, this is a Jupyter thing where you display things. If you write this in a script, it will not be displayed unless you put it inside of a print statement, instead of a print, instead of putting this expression as an argument to a print function call, which would be a print statement. I'm just trying to use the official language they're describing. and that is intentional, right? Any evaluation is not automatically displayed, right? That is also a process that needs to be done. Um, it's just Jupyter does some fun stuff that allows us to do it right away. Um, I think you can do it in the REPL as well. Let me try that. Python 3.112 print hello world. Oh, I'm just gonna go hello. I think I have to give it the -c unknown file attribute etch. I think I just need to run it as the REPL. 3 plus 2, 5. N equals 3. 3 plus 10 plus 3. Okay, so also in the REPL, it does display it. So, and in the REPL, it doesn't matter actually. You can still display it as many. So I could do n plus 5. It's just going to get displayed immediately. Whatever you put in is evaluated immediately. Whatever expression needs to be evaluated, whatever statement needs to be executed, it'll just run immediately in the REPL. So I'm just going to quit. There you go. Quit that. So that's how it is in the REPL or the idle. I don't know what it's called. The something something. Basically, this is just you running Python in interactive mode. Let's put it that way, right? Versus writing a script and then just having everything be executed when you run that script. It also works with floating point number. Okay, yeah. Oh, you already got through this. Okay, yeah, so you can print multiple things and separate it by commas. Notice that print functions put spaces between the values. So if you do this, it'll be blah, 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 space, blah, right? And as we saw earlier, we can modify that if you hover over print. Why is this not showing? There you go. There's sep, which is defaults to space, which you can change. And then there's end, which is defaults to new line character, which you can also change. These are just arguments to print. They're all, I think, keyword arguments because all the positional arguments are seen from before as start args. String appended after the last value, default to new line. A file-like object stream defaults to the current std out. Flush, whether to forcibly flush the stream. I'm not sure what that's about. I think that's essentially like there's a streaming buffer. I believe that's what this is about. So there's a streaming buffer. So instead of actually printing straight to the terminal, it gets saved in memory someplace. And once that buffer runs out, things get printed. And yeah, just to be like, hey, I don't care if the buffer is full or not. Just make sure to flush it, and send this message out immediately. In just like basic starting up development, that's not going to be something that matters. But if you've been watching my previous videos for things like logging, you'd want to set that up so that it flushes immediately. And I think you can do that with a environment variable as well when you run Python or when you run a Python script. But I'm not sure. We're not going to get into that. So notice that the print function puts a space between the values. It's just like showcasing what I just talked about, the different arguments that print can take. So we're going to talk, and hopefully they'll get into star args themselves. But whenever you see star args, right, essentially that means just any number of positional arguments to a function. And the difference is that a positional argument is something you just need to give it in the order that it's defined in the function. And then keyword arguments are arguments that you need to give it, like sep equals whatever separator you want, right? So for example, I could do sep. So I've now passed in all the positional arguments here. So one is the actual string, and the second is math.py, and then I could I'm done with positional arguments. I have to do I'm gonna do keyword arguments. Sep equals we'll just hit tab instead of space. Let's run that, see if it, okay. Tab. Yeah, okay, so the separator is massively increased, as you can see. And note you can't pass in some other maths.py CBRT. It's, right, I can't print that. I can't do that. Why a positional argument cannot appear after keyword arguments. So you just highlight this. Just always highlight the red squiggly lines and things like that. And just create problems, make issues, figure it out. That's the thing in the end of the first chapter, and it's 100% true. So yeah, that's just how that works in Python. You can't have positional arguments, keyword arguments after positional arguments, and you can accept a arbitrary number of positional arguments if you name it star args. It's another additional nuance there that I'm not getting into right now. When you call a function, the expression in parentheses is called an argument. Normally I would explain why, but in this case, the technical meaning of a term has almost nothing to do with the common meaning of the word, so I won't even try. Yeah, so that is true. These are called arguments, and honestly, the better term would be a parameter. Argument is just not vocabulary makes sense in my thing. Just give me a moment. I need to pause the recording. All right, so back to this. So yeah, arguments, that is what it's called, and it just doesn't make sense. Actually, it's just one of those things where we call it an argument, but it has no vocabulary based connection to the actual word, which is it's something I tell most people, like, hey, look up the words. 9 times out of 10, not always, 9 times out of 10 though, it will display, or it will explain to you what something means, right? So syntax error, for example, that's like really straightforward, makes complete sense just by if you know what a syntax is and what error is, right? Like the literal dictionary definitions, I mean. Alright, I had to pause again just real quickly. Arguments. When you call a function, the expression parentheses, and I will explain this why, but in this case, the technical meaning of a term has almost nothing to do with the common meaning of the word, so I won't even try. Yeah, that's just true. Some of the functions we've seen so far take only one argument, like int. Some take 2, like math.pow. Some can take additional arguments that are optional. For example, int can take a second argument that specifies the base of the number. So 101 with base 2 is 5. Round takes also 2 arguments. The sequence of digits 101 and base 2 represents the number 5 in base 10. Round also takes an optional second argument, which is the number of decimal places to round off to. Yeah, that's true. Some functions can take any number of arguments, like print. Print can take any number of arguments, as we discussed with star args. If you call a function and provide too many arguments, that's a type error. So you'd get a type error here because float doesn't take more than one argument. Or maybe, let me see, let's just hover over this. Converts a string or numbers to floating point number. Why is float star args and star kwargs? That means it can take an arbitrary number of positional arguments, an arbitrary number of keyword arguments. I don't understand. That doesn't make sense, but whatever. If you provide too few arguments, that's also a type error, yeah. And if you provide an argument with a type function that can't handle that, that's a type error as well. Yep. This kind of checking can be annoying when you're getting started, but it helps you detect and correct errors. Yeah, very true. very true. Definitely recommend. Comments. As programs get bigger and more complicated, they get more difficult to read. Formal languages are dense, and it is often difficult to look at a piece of code and figure out what it is doing and why. For this reason, it is a good idea to add notes to your programs to explain in natural language what the program is doing. These notes are called comments and they start with the hash symbol. Yep, that's exactly what it sounds like. So basically this first line is not evaluator or executor, and you can just write whatever you want there, and it's really helpful for code that is getting hairy. Okay. Yeah, so you can also put a comment at the end of the line. Anywhere you put hash in a line, anything after that is just ignored, basically. In Python, not in all languages, but in Python, yes, hashtag is a reserved value for comments, essentially, and in a lot of other places, not just Python, but yeah. Everything from the hash to the end of the line is ignored. It has no effect on the execution of the program. Comments are most useful when they document non-obvious features of the code. It is reasonable to assume that the reader can figure out what the code does. Is more useful to explain why. This comment is redundant with the code and useless. Exactly. Assign A to B. The comment contains useful information that is not in the code. V equals A. Velocity in miles per hour. There you go. Good variable names can reduce the need for comments, but long names can make complex expressions hard to read, so there is a trade-off. Yeah, good variable names can reduce the need for comments, but long names can make complex expressions hard to read, so there is a trade-off. Yeah, that is 1000% true. I've seen that happen multiple times, so yeah, that's a thing. Also good doc strings, good documentation. We'll get into what doc strings are later, if needed, hopefully not. Debugging. 3 kinds of errors can occur in a program: syntax errors, runtime errors, and semantic errors. It is useful to distinguish between them in order to track them down more quickly. Syntax error. Syntax refers to the structure of a program and the rules of Syntax error. Syntax refers to the structure of a program and the rules about the structure. If there is a syntax error anywhere in your program, Python does not run the program. It displays an error message immediately. Runtime error. If there are no syntax errors in your program, it can start running. But if something goes wrong, Python displays an error message and stops. This type of error is called a runtime error. It is also called an exception because it indicates that something exceptional has happened. Semantic error. The third type of error is semantic error, which means related to meaning. If there is a semantic error in your program, it runs without generating error messages, but it does not do what you intended. Identifying semantic errors can be tricky because it requires you to work backward by looking at the output of the program and trying to figure out what it's doing. 3 kinds of errors can occur in a program: syntax error, runtime errors, and semantic error. Useful to distinguish between. Okay, yeah. So this is not a Python specific thing. In fact, in Python, there is no exception that will be raised called syntax error, like we saw, I think here also somewhere. Yeah, see here, 76 trombones. So these are syntax errors. That error is an actual error that will be raised by Python, but these other 2 are just more generic descriptions of types of errors, right? And these are essentially 3 types of errors, right? Syntax error, you wrote something in the wrong way that the language doesn't make sense, essentially. Runtime error, okay, you did something that technically fits within the rules of the grammar of the language, but you did something that doesn't make any sense, so the program crashes out. So I think a good I'm trying to think of an English way to describe runtime errors. You could say a runtime error is if you were to construct a sentence that doesn't make sense but is grammatically accurate, that would be like a runtime error. I'm trying to think. I am flabbergasted. I am flabbergasted by urine. I couldn't think of anything else. And technically, someone could be flabbergasted by urine, I guess. but like just to be surprised and or shocked just by your in general doesn't make any sense, right? Obviously, sometimes context can fix that, but you get what I'm saying. Basically, it's an issue that happens when the program is running, right? Some type, and it's type mismatches could happen. Like, for example, you're doing some computation that requires like two integers or two numeric types, and one of them somehow ends up being a string or whatever. So there's no syntactic error, but when you run it, it's like, what? No, I can't do this. This doesn't make sense. And it'll throw some sort of more specific error, like I guess it would be a type error in that case that would be raised at runtime. And then there's semantic errors, and this is the worst kind of error. Essentially, it's basically, this is like the real bane of debugging, because the other two are usually fairly easily catchable and fixable. Well, runtime errors can be also tricky sometimes, like, because if you have a really complicated program and a variable is being passed through multiple functions, then yeah, things can get hairy, but still. And then there's a semantic error, wherein essentially code works, doesn't crash, it's not doing what you want it to do, right? So those are the worst, right? And it's because like programming and mathematics and Python, obviously, as part of that group, is a formal language, so things are very specific. So if you didn't describe what you wanted with the language in the exact way that it can understand, it will do something else, right? It will do what you tell it to do. They're dumb. Computers are dumb. They're really stupid, genuinely. Even the AIs, they're so stupid. Anyways, so as we've seen, an illegal variable name is syntax error. Yep. And if you use an operator with the type it doesn't support, that's a runtime error, because this will only be caught at runtime, right? Like the code just won't even start up, right? But like code will start up, things will start running, and then if for some reason this happens somewhere in your code, that's a runtime error, because it's hard for you to see how these are different types of errors. And 1 plus 3 over 2, it does not produce an error message, but the result is not the average of 1 and 3. So the program is not correct. This is a semantic error because the program runs, but it doesn't do what it's intended. So yes, that is a semantic error, and that's an easy one to fix. You just wrap these in parentheses. That's a math thing, right? So anyways, that doesn't even matter. Yeah, it's kind of hard to understand that from these, but yeah. Ooh, we have a glossary. I actually quite like these glossaries. They're very, very detailed. I quite like it. For I think someone who's picking up, copying and keeping these glossaries, this glossary somewhere is nice. And having like a common language in terms of how you're communicating with other people in the profession is important. Well, it's not as important. I think you can be a great coder without necessarily having the right syntax of communication, let's put it that way. And honestly, the syntax can be so much that it's impossible to know all of it, but we should all try, because it does make conversations easier with someone, especially when you're talking about very specific things. Ask a virtual assistant. So I did not do that last time. I'm definitely not going to do that this time, but I'm going to look at these questions. Why is class a keyword? Because that's how you create classes. Why can't variable names be keywords? Why can't variable names be keywords? I'm gonna, I don't understand how you can be used as variable names. Okay, fair enough. Yeah, that's actually correct. Yeah, I was just major malfunctioning on the question. I was like, what does this question mean? What? But yeah, we actually talked about that earlier. You might have noticed that infloat and stir are now Python keywords. They're variables that represent types, and they can be used as functions. So it is legal to have a variable or function with one of those names, but it's strongly discouraged. Yeah, so we talked about this, where you're just shadowing the scope. You're shadowing a name that is not necessarily a reserved keyword, but something that is used elsewhere in the language, like in a function or a module you imported or whatever, or in the case with infloat and stir, just like a generic part of Python. It's a terrible idea, because if you don't write your code exactly perfectly, the code can misinterpret and like call the wrong things. Um, right? For example, if you use I don't know, float as I don't know, even give an example. It's just a terrible idea. Don't do it. Also ask what are the built-in functions in Python. If you're curious about any of them, ask for more. There's tons. There's so many. I'm not going to do that. In chapter important math modules over what variables and functions are in the math module. Other than math, what modules are considered core Python? Yeah, so there's several. Um, there's several. I'm not even getting into that. I don't really care for me, but if you are watching this, you should look these things up, right? And honestly, I don't. It's saying virtual assistant, aka ChatGPT, but just Google these. A lot of these have good Googling answers, and Google also has its own AI overview thing. But then the links are pretty close by, so you can see the AI overview, which it speaks to you in a very specific kind of dumbed down manner, and then double check the comment that someone else makes and try and read it and see if you can actually understand it from the source, because sometimes the source is more dense, and just that process not only cements what you were looking up, but you'll also end up learning other things. Okay, repeating my advice from the previous chapter, whenever you learn in your future, you should make errors on purpose, blah blah blah. See what goes wrong. Seeing that n equals 17 is legal. What about 17 equals n? I don't think that's legal. I'm gonna do that. I'm pretty sure I'm just gonna do 1 equals n. Cannot assign to a literal here. Maybe you meant equals instead of equals. Yeah, so that makes sense. You cannot assign a literal value to a thing. That makes a syntax error. In some languages, every statement ends with a semicolon. What happens if you put a semicolon at the end of a Python statement? I'm not sure. No, I was recording for a moment. All right, so just continuing on once again. Yeah, so what does ending with a semicolon does? Nothing. What if I do print? Does it? I don't think a semicolon does anything in Python. Does a semicolon do anything in Python? I don't think so. Okay. Oh, okay. So if you don't want to do it on a new line, you can just hit semicolon, which is actually really nice. Yeah, okay, so these are syntactically valid but are considered unPythonic. Python's design emphasizes readability and placing multiple statements on a single line with semicolons. Yeah, okay. I'm gonna go back to this. Yeah, that's what I thought. What if you put a period at the end of a statement? That'll be a syntax error. Yeah, because it's like the dot operator, essentially. It's expecting like, okay, I'm getting something from this, but there's nothing to get. Every statement, what happens if you spell the name of a module long, try to import math? I think you'll just not import it. It would throw some sort of error. Yeah, module not found error, there you go. Yeah, but these are the kinds of things you should do if you're starting off. Practice using Python interpreter as the volume of sphere with radius 4/3 pi RQ. What is the volume of sphere with radius 5? Start with the variable named radius and then assign the result to a variable named volume. Display the result. Add comments to indicate the radius centimeters. Volume is cubic centimeters. Rule change, blah blah blah. It's just some mathy stuffs to help you practice. In addition, pi, the other variable is e, which expresses the base of a natural argument written in math notation as e. If you are not familiar with this value, ask what is math.e. So yeah, that's just like, I think that's Euler's number? I forget what it is exactly, but I'm not gonna look it up, but you should. Math.pow to raise math.e to the power 2, math.exp, which takes argument x. So some basic stuff. I'm not actually gonna code this up, but yeah, it's good things, and I think this is a good overview. I'm gonna try and go through these as quickly as possible and get as many of these videos done as fast as possible, because I think that would help me help other people get set up quicker. All right, that's it for today. Thank you so much for joining. Hope you have a good one. Take care. Bye bye.